Well, hello, and welcome to Levine Geometry 8.7, Surface Area. We are going to cover how to find the area of different three-dimensional shapes on the outside of those shapes. We're not working on volume, so go ahead and write 8.7 surface area. We're not finding the area inside of objects, we're finding the area of their surface areas. So go ahead and write this definition. Surface area, the sum of all the faces or surfaces that surround the solid. Okay? The sum of all the faces. So you're looking up here and you see bases and lateral faces. Those are our two big terms. Bases and lateral faces are our two big terms. So pause, finish writing surface area. I'm going to move on. Like I said, lateral faces and bases. You can make a rap song out of this. Taylor Swift could make a wonderful love song out of this that would move all of you to tears. But lateral faces are the faces between the bases. That's what I'm talking about. Look at the rap song. Look at the possibilities. The faces between the bases. That's how you're going to remember this. The faces between the bases of a prism or the triangular faces of a pyramid. So, if you have the lateral face, your bases are going to be your top and your bottom. They're going to be congruent, and all the outside of the shape that connects those two bases is your lateral faces. While the bases are the congruent, parallel faces on a prism or the face that does not touch the tip of a pyramid. So if you look at this, you can see over here you have our bases. They shaded in kind of this area, and they shaded in kind of that area right here. That's your bases. They're on the top and the bottom. They could be on the left and the right, but they are congruent, and they are parallel to each other. Then you have the base that could be with a pyramid. There's not going to be two sides of the pyramid. One side's going to be a tip. So it's just the part of the pyramid that does not touch the tip. Go ahead and pause this and write these down. And here's the steps to finding surface area. There goes the bell that says to go home. So I hope you're home. Steps for finding surface area. First, draw and label each face of the solid as if you would cut the solid apart along its edges and laid it flat. What he means by that is all 3D objects can almost fold out. If you fold out the shapes, they're going to form a 2D object laid on the ground. And I will show you this in class. If you can label each side, that's going to be huge. Calculate the area of each face. So we've got to calculate the area of each one of the faces. So I'm going to go back, and if you look, the lateral face, that's a rectangle. This right here is a rectangle. You've got to calculate the area of that rectangle. And then you've got to calculate the rear area of this polygon. Okay? You've got to calculate all those areas. And we go back. And then you've got to add them up. That's how you find the total area of all the faces. You find the area of each face, and then you just add them up. So pause this and write those steps for finding surface area, please. Here is an example. Find the surface area of a rectangular prism. So we look and we see we have 1, 2, 3, 4, 5 down here, and then your top is going to be 6. It's the top of this. So we have 1, kind of this side right here, 2, this side, 3, this side, 4, this side. You got the top of it, and then you got the bottom of it. Bottom and top. Okay? So we mark all those. We've got to find the area of each one of those. So if we're looking at this part, well, that's 8. It's a rectangle times 3. Because the 3 is right here, so that has to be 3. Okay? That's that one. And then on the other side, it's the same thing. It's going to be 8 times 3, so there's 2 of those. This side is 8 times 3 as well. Then over here, we have 6 times 3. We have 6 times 3. So we're adding 2 times 6 times 3. Because this side is also 6 times 3. Then we're going to have the top and the bottom. And the top, we got 8 right here, and we got 6 right there. So that's 2 times 8 times 6. And that's our problem. We do all these calculations, and that's the surface area. So we get 48 meters, 36 meters, and 96 meters. And we add those up, and that's going to give us our answer. So again, every single time, you have to find the area of each one of the parts of that object. It's always going to be a shape that you can find the area of. And then you add them all up. And the area is meters squared. These are squared as well. 180 meters squared. So that's an example. I'm not going to do a ton of examples. Find the surface area of the cylinder. Okay, it's the same thing. You're going to have to find the area of the circle, which is pi r squared. And r is half of 10, so r equals 5 inches. So it's pi times 25, and that's in inches. And there's 2 of those, so you have to multiply it by 2. So you end up getting 50 pi inches for this circle and for that circle. Then you have to find the area of this shape. Okay? To find the area of that shape, you have to do 2 times pi times r times the height. Because you have to find the circumference, because what you're getting is you're getting this part of the object, the circumference, not the area, times the height. So that's going to be something you have to remember. It's going to be 50 inches plus 2 times pi times r, which we just said was 5, times the height, which is 12. Okay? So that's going to be part of the equation. I'll write down that in a second, that equation you're going to have to know. But that's going to be 50 pi plus 120 pi. And that's just 50 plus 120, which is 170 pi inches squared. But here's what you got to know. You got to know the equation for cylinder, and you got to know the equation for pyramid. And here they're just kind of showing you their slant height, which is L. And then there's the regular height, which is straight up perpendicular from the bottom to the tip of the pyramid. Okay? There's slant height and there's straight height. I would like you to do your best to draw this. Okay? It's going to be really good to know. But I'm pause it and draw it. I'm going to move on. You have surface area of a regular pyramid. And this is what I'm talking about, where you can see the shapes folded out. If I fold this shape out and make it 2D, you have all of these shapes, and then you have the base right here. So if you want to pause and kind of look at this, this gives you a good idea of what I mean by folding out. They become 2D shapes. So we look, what is the area base of any regular n-gon pyramid? That's the question we're asking. We're not going to do the investigation. The surface area of a pyramid is 1/2 times the number of sides times the base plus the slant height, which is L, okay, plus the slant height plus the apothem, which is the regular height. These are the equations you got to know. So please write surface area of a pyramid down and write this down. We'll spend more time on this in class. This is a difficult topic. Go ahead and pause this. Surface area of a cone, and that's it. So I'm going to go ahead and write these down. You have the surface area of a regular pyramid. That's what a regular pyramid looks like. And you have the surface area of a cone. Do not confuse these. They look very similar, but a cone has the circle on the bottom. The regular pyramid has the polygon on the bottom. And the regular pyramid is 1/2 P times L plus A. You should have already written this one down. You can write it down again if you would like in a more organized fashion. And then you have cone, which is pi r times L plus pi r squared. And again, that's another one we kind of went over. Go ahead and pause this here. Make sure you have these equations down. If you already have them down, star them, make sure you know them. If you don't, go ahead and write these down. These are very important. But pause this. As we move on, there's different examples. We will do a lot of these in class. But again, A is the apothem, S is the side, length, H is the height, D is the diameter. You're normally going to want the radius. And that is it. So I hope you enjoyed the video. I hope you understand the basics, and we are going to work on this a lot more. It is confusing equations. So we're going to work on this a lot more in class. Have a good night.